Hi, welcome to StatStuff. I'm Matt Hansen. In a previous lesson, I briefly described the difference between population and sample data. In this lesson, we'll dig a little deeper into those differences. There are no prerequisites for this lesson, so let's begin by defining what is a population.
Well, population basically represents every possible observation that's available. It's ideal if we can measure a population, but it's very rare that we can actually get access to the entire population, and often unnecessary for us to actually do so. So instead, what we often do is refer to a sample. Now, a sample, instead, is a subset of the population, and that subset is intended to have a fair representation of that population. We can use a sample size calculator that's going to be covered in a separate lesson that can help us to estimate how big of a sample that we need in order to fairly represent that population. Now, if we have an adequate sample, that can allow us to make certain inferences about the population itself. So when we say it's making inferences about the population, it's kind of like saying it's statistical prejudice. I know that's not very politically correct to say that, but that's basically what it is, that we have some smaller group that, based off of the smaller group, we're making some judgment or inference about the much larger group that we expect that smaller group to represent. Then the differences between the conclusions that we have from the sample versus the reality is risk. And that's really the problem, even the problem that we see with prejudice, that sometimes we're making certain conclusions based off of a small sample or some subset, and we could be wrong from those conclusions and expecting it to apply to a population when maybe it really doesn't. Well, those differences between where we are in the conclusions from a sample versus what the reality is in the population, that difference represents the risk. So prudent statistical analysis will demand that we at least try to mitigate that risk as much as possible or as much as necessary. And we determine how necessary that is by looking at the VOC, or the voice of the customer, and what is important to the customer and how necessary it is for us to reduce that risk. In sampling, what we use is precision, or like margin of error, as a way to represent that risk. So just to use a visual example, we might have a population represented here, and from the population we're taking certain groups out of the population and we're saying all those groups of people that we're looking at represent some sample. Now the risk again is that we want to know, does this sample that we have from the population, does this group truly represent the entire population that we're trying to evaluate? This is kind of like a practical application of how we might look at population versus a sample. Now, from a statistical standpoint, the application would be that we're looking at our data across some scale, across some line, the continuous data. And based off of the data we've collected, if we knew the actual data for the population, it might be represented by this type of normal distribution here. And being a normal distribution, we might measure the central tendency using this, the population mean. Well, this is about the middle point. Again, the central area where most of the data points tend to fall is how we might refer to the central tendency. Well, this might be the measurement we use for central tendency for this population, and we call that the population mean. But if we were taking a sample, now the data set that we have is a lot smaller. It might look again like it's a normal distribution. It might look really similar to the population, but the actual mean that we collect from that sample will be a little bit different. It would be the sample mean, represented by the X bar here. Now what we want to look for is, what's the difference between the sample mean, where we think the central tendency is based off of the sample we've collected, versus the actual population mean that we're intending that sample to represent. The gap between these two represents the risk, and we need to understand how big of a deal this is. If it's low risk, the fact that there's a difference or a gap between them, then maybe that's okay. And again, as long as the customer is okay with that, then that's what's important for us to understand. However, if this risk is a big deal, if it is that important for us that we need to narrow this gap as much as possible because the customer believes that's what we need to do because it's high risk for us, then that's what we need to understand. And having this difference in understanding population and sampling, and the difference is represented here again as the risk, is what we really need to understand and how we can mitigate that risk.
All right, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way.
I'd like you to identify at least 3 different metrics that are used in your organization that rely on sampling in some way. These could be customer surveys, employee surveys, or it could be a QA group, a quality analysis group that is doing some sampling on actual widgets or transactions for validation purposes. Whatever it is, basically something that is used as a metric in your business that uses a sample rather than looking at a population. And for those different metrics, I'd like you to ask yourself these questions. What methods are used for actually selecting the sampled group? That is, how do they know what sampled group to actually select? And do you believe that those methods that they're using are truly random? Are they actually using a true random representation when they collect the sample from the population? If you don't think so, then why is it that you might doubt that they're using a truly random method? And also, how accurate do you think those sample metrics are in actually reflecting the true population? Do you think they're that accurate or not? And also, what's the risk if the sample metrics don't actually reflect the population? So if you think that maybe there is some difference there and it doesn't truly reflect the population, is that a big deal or not? Is it a high risk? Or is it close enough that maybe for what you do in your business and what's important to your customer and who you're serving, that maybe it doesn't matter that there is some difference? That's what I'd like you to consider there. Also, what does your organization do in order to mitigate those potential risks? So if your organization actually believes the risk of having the sample be very different from the population, if they think that's a big deal, then how does your organization handle that? What do they do in order to mitigate that risk and to ensure that their sample truly does represent the population?
Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.